SCP&E Solutions was challenged to design a renewable energy solution for Hala Industries, an advanced uniform manufacturer for California bases, which is why a wind turbine was chosen due to the pros found during research. Another one of the goals of this project is that by the end of it, students will be able to demonstrate ample understanding of subjects like vibration, axial and transverse loads, as well as statics. Moreover, the students will get a good sense of what it is like to work alongside other professionals with distinct working techniques, schedules, and perspectives. Many prototypes were created during our time in this project. For example, during Phase 1, Emma and Christopher were in charge of creating our tower. However, some difficulties that they encountered that resulted in them changing part of the prototype was its weight. Because of this, the first sub-team that was in charge of the tower had gone overweight by a bit, and one core beam had to be removed. The prototype that was created in Phase 2 by the second sub-team was not only rushed, but also over-designed. The tower was so heavy that we had to take off almost 4.5 core beams. During Phase 1, Susanna and Peter were in charge of making 2 different designs for the blade and coming up with the final design that would outperform the other 2. Each person made their own design and constructed it, however, only one was chosen at the end. We worked off of Peter's design and simply made some simple alterations to make it aesthetically pleasing, but also to find the angle and the different cuts that would perform better. Emma and Christopher decided to go with a simple design that generated almost 4 voltages. They utilized balsa wood sheet as their only material, while the other sub-team used poster paper glued onto construction paper for support. However, the only test we failed was the blade test during Phase 2, as the blades were ungluing from the dowel, therefore not allowing the blades to reach their full potential, nor generating as much voltage as it should have.
Our design included symmetrical and aerodynamic components that were inspired by elements of modern architecture and amateur rocketry. More specifically, the blades had the shape of the cross-section of a hack series nose cone, and the tower had a futuristic design with unaligned structural blocks laying on top of each other. Regarding the construction of the wind turbine tower, the team tried several different materials for the blades, ultimately concluding that balsa wood was the best choice. As for the tower, we could only use cory beams and hot glue. However, the team decided to use raised frames to increase resistance to lateral loads, diagonal internal beams, and L brackets to increase redundancy.
To start off on our experimental methods and results, we're first going to look at our blades. So our blades during Phase 1 reached 0.225 volts, and the PI calculated was 162, while during Phase 2 the blades only reached 0.174 volts, and the PI was 81.745. During Phase 1, we saw how the blade shape used in the final iteration performed best out of all of our different tries, so we try to recreate it with a different material and by adding another blade. When testing during Phase 2, though, the blades did not work as well as they had prior to the official testing. With another iteration, the team would try to figure out exactly what angle the blades performed at best consistently and also make sure that the blades are fully intact so they have no issue running. Now to look at our towers. During Phase 1, the tower was able to withstand a force of 9.5 pounds, and during Phase 2 could withstand 14.025 pounds. The PI during Phase 1 was 191.4, and the PI during Phase 2 was 224.8. Phase 2 had a higher PI due to it being able to withstand more force, but in another iteration, if we were able to increase the height while still being able to maintain the amount of force applied, the PI would be increased for both our tower and blades.
Structural analysis was conducted to understand the performance of our tower under different loads. Our team designed our tower as a brace frame structure using one-dimensional elements such as columns, beams, and diagonal beams. These components would distribute loads going from one component to another, starting from the top of the structure to the body and foundation. Upon testing our first design, we noticed that our top portion of the structure had a few diagonal columns supporting the weight on one side, which fell by bending to formation. We resolved this issue by adding more support to the area where it fell. The maximum moment was 304 pound force inch. The second tower design had a force of 14.052 pounds at a distance at 27 inches, which was higher at 379.4 pound force inch. The factor of safety is essential for the structure, as the man must not exceed the capacity, which requirements were met upon testing. The tower resisted a load of 12 pounds in compression and above the minimum transverse load of 8 pounds. The blades of the wind turbines were designed to be lightweight to keep the structure standing and functioning properly. The blades produce a high voltage of 0.225 above the requirement, which will provide renewable energy solution for Hala industry.
Designing and constructing this wind turbine tower put our knowledge to the test and stimulated our creative thinking. The team developed a functional structure that made the stated requirements, and everyone collaborated in such a way that our ideas were heard and applied. However, although our structure passed the tests and did not get disqualified, it was clear that our execution could have been better. All in all, even though our design ideas were promising, executing them in such a short amount of time was detrimental for our performance results. Still, there's no doubt that our time spent on this project will have positive consequences in our experience as structural engineers at UCSD and beyond.